Okay, I'm here on the IUS campus, Indiana University Southeast, at the Gerald D. Ruth Observatory. With the telescope here, the main telescope in the dome, is a plane wave CDK 17. It's a 17-inch diameter mirror. And I decided to use the facilities of Level 1 Hackerspace in Louisville to make a Botanoff mask, which is a focusing aid. Botanoff mask looks sort of like this. I found a website that allowed me to calculate out an SVG file to use on a laser cutter. I cut it out of coroplast, black coroplast. It's polypropylene, so it would hold up over a few years. Because the CDK-17 has a spider that has a cylindrical socket, shall we say, in the middle. It's about 6 inches internal diameter. I decided to make, in effect, a rubber stopper for this to hold it out of EVA foam, basically craft foamies. And it allows me to do this, to go up here and plug it on like a vacuum stopper. So when it's on there, and you see how easily it is moved, when you use a Botanoff mask, it causes a diffraction pattern that can be interpreted fairly easily to find a critical focus on a bright star. And then you can use that for photography. At any event, one project for the week at the IUS Observatory. Here at this part at the IUS Observatory, and another project I worked on deals with this recently cleaned up and brought out of mothballs Celestron C8 telescope on an old Wasmby mount, G11 mount. It's fairly hefty. It's a good mount. Doesn't have go-to, but it has pretty good tracking. Solid as a rock, but it's heavy. It weighs well over 100 pounds with the equipment on it. And in the past, I've had to pick this thing up bodily, grab underneath it close like this, and try to lift it and carry it, get it in and out of this storage building. I'm getting older, and that process is getting older. So I decided to do something about it. So what I did was I bought 3 of these little $8 appliance dollies with 3 wheels, plus a couple. I bought 3 little PVC caps, 2-inch. They're for 1 1/4 inch pipe. They're about 2 inches in diameter. The idea is that the legs on this telescope are hollow inside, so I can sit the leg down over this by putting it on the ground like so, leaning it back, and keeping it in the position here. And once it's on there, I have wheels on the telescope, so now I can easily roll this thing in and out of the building. A big improvement is I'm getting too old to lift 100 pounds and carry it in and out of the building every time I want to use it. When I came up with the wheels adaptation for this telescope, my original plan was to simply wheel it out in position and then lift the legs up and kick the wheels out. It's turned out a little more difficult than it looks because it keeps rolling around. You do have to have the feet on the ground or in contact with the ground solidly to keep the telescope moving while you're using it so you can stay aligned. Being on the wheels by itself wouldn't work because it wouldn't take much of anything to bump it, move it while you're using it, and then the alignment's off and it won't track properly. So I thought, what can I do about that? And I came up with another plan. Toggle clamp looks like this. It pushes a rod here. This is a push-pull toggle rod. when I push this lever this way, it locks into position here, and I can fold it back out of the way. So if I put this on the leg, I can extend this down below the wheels and pick it up off the ground, maybe 1/4 of an inch. And that should lock it into position. All I'd have to do is go around and flip the 3 levers down and lock it into position. I've designed a way to adapt these toggle clamps onto this by drilling some holes. I'm going to drill some holes into the feet of this telescope, and I had to make a template for how to drill the holes so that I could get the screws to go in perpendicular to the surface, so they all point toward the center of the tube. That gives the maximum strength for holding everything in position. So I will demonstrate that shortly. I've taped a paper drill pattern down onto as a template for where to drill holes on these legs. I've done the math, calculated out the exact position to put the holes so that the screws will go in perpendicular to the sides of the tube and still go through the holes on this. They're coming in at an angle. So the intent is to drill them in exactly the right spot and go straight in. So we'll see how that works out. And now that I've got the holes drilled, pilot holes drilled, I won't need the template anymore. Each one of the toggle clamps will have a piece like this underneath it to stabilize a piece of low C channel there. Need to re-drill the holes to make them fit the screws now. Okay, I've re-drilled the pilot holes with 11/64 bit so that the screws, the number 10 screws, will bite but not wind up. So I should be able to self-tap these things by screwing them in hard. Double checking that everything looks like it's going to fit here. First, verify I can drill the hole. Put the plate on underneath. Get back to the second one. Okay, now that I've got it screwed in and adjusted a little bit, you can see how this works. In this position it rolls. I'll flip this down and push on it. It's sitting on the pin and the weight's off this. You back up, I can roll it again. Now that I've got all the work done on all three of the wheels, I have toggle clamps on all three wheels. I can demonstrate wheeling it out. I can wheel it out of the shed, aim it more or less toward north, like so. Then start clamping down the clamps. I clamp the one in the front first, makes it a little easier to make a fine adjustment here. Then clamp that one and this one. Now, the thing is sitting on the clamps now, it's not sitting on the wheels. And demonstrate that by the fact that the wheels kick around now. All three. So, this is the second project for the week for the IUS Observatory. Getting the old Celestron Losman mount portable again. It used to be such a pain to get this thing out of here and put it away. Now I can just wheel it out, clamp it in place.